Another radical equation, but this time in code. When the square root of 2 less than a number, okay, start small, 2 less than a number, there's a number, there's 2 less than a number. Now they say the square root of that number. Okay, so far, that's the square root of 2 less than a number. You're often reading from right to left when you're doing these. The way that English says these things and the way that math says them are not always consistent. So the square root of 2 less than a number is subtracted from, oops, that means we're taking this away from something that came before, the square root of, there's another square root, and what goes in there? 5 more than twice a number. Here's twice a number, and now 5 more than twice a number, and then this symbol makes it the square root of 5 more than twice a number. And finally, they say the result is 3. So there's an equation to represent all that. Solve the equation. Well, it's got 2 roots, and you know how we deal with that. We have to isolate. We'd isolate them both at once if we could, but since we can't, we pick one, isolate it, and then repeat. So I will take this to the right-hand side. Yes, you could move the other one. I'm moving this one because it'll become positive when it moves over, and positives make me happy. So we get root 2x plus 5. And on the right, we get root x minus 2. It's positive now because it moved sides, plus 3. When we square both sides, that gets squared. And on the right side, instead of just writing to the second power, I'm going to write it out twice because we have to FOIL it anyway. Might as well get ready. Good? So when we square the left side, the square and the square root cancel each other out. We're just left with the radicand, 2x plus 5. On the right side, root x minus 2 times root x minus 2 gives just x minus 2. Outside, we get 3 root x minus 2. Inside, we get another 3 root x minus 2. Total of 6 root x minus 2. And last, we get 3 times 3 is 9. So, progress. We went from having 2 radicals to just having 1. Now, I want to isolate this radical, kick everything else over to the left-hand side, and then we'll square the whole equation again. So 2x minus a single x here leaves a single x. Then we have 5 plus 2 once this comes over gives us 7. And then 7 take away 9 leaves negative 2. Right? The 2 becomes a positive when it comes to the left. The 9 becomes negative when it comes to the left. And on the right side, we have 6 root x minus 2. Now that we have this radical by itself, square both sides. And yes, I'd like to write this as x minus 2, but because it's on the left-hand side, I don't have room to do it. Unfortunate, but it happens. So that means x minus 2, I'll do it on the next line, equals 6 root x minus 2 all squared. On the left, first gives us x squared, minus 2x minus another 2x is minus 4x, negative 2 times negative 2 makes 4. And on the right, 6 squared is 36, and then we get x minus 2. X squared minus 4x plus 4 equals, this 36 distributes, so you get 36x, and then you get 36 times negative 2, which makes negative 72. And finally, almost there, take both of these to the left-hand side. Because this is a quadratic, we want it to equal 0 so that we have the zero product theorem to help us. So x squared, we have minus 4x minus 36x total minus 40x. We have 4 plus 72 makes 76, and that equals 0. So factoring this, we need two numbers which add up to negative 40 and multiply to 76. Well, there's the obvious way to make 76. It's also 2 goes into 76 38 times. This looks good. Negative 2 and negative 38 will do what we need here. X minus 2, x minus 38 equals 0. If you solve that by the zero product theorem, you get that either x equals 2 or the other possibility is x equals 38. Do they work? Are both solutions valid? To find out, we plug them back into our original expression. If I use 2, I get root 2 times x plus 5 minus root x minus 2 equals 3. 2 times 2 is 4. 4 plus 5 is 9. The square root of 9 is 3. Minus 2 minus 2 is 0. The square root of 0 is 0. So this left side becomes 3 equals 3, which is pretty obviously true. So the solution x equals 2 works. It's valid. How about the other one? If you use 38, plug it into the original equation, here's what you get. 2 times 38 plus 5 minus root 5 minus 2 equals, we hope, 3. 2 times 38 is 76. 76 plus 5 is 81. The square root of 81 is 9. Minus 5 minus 2 is 3. Oh, I'm sorry. Where did I get 5? It's supposed to be 38. The square root of x minus 2, I'm supposed to be putting 38 minus 2. I spaced out and put the 5 here. 38 minus 2 is 36. The square root of 36 is 6. 9 minus 6 equals 3, so 3 equals 3. Unusual, but it happened. We got an equation where there were two solutions, and they're both valid.